Hey guys, this is our video on MAF and MAP sensors. So as you can see here, we're looking at a MAF sensor wiring diagram for an '06 Suzuki Vitara. That black and blue wire coming in is ignition voltage. The red wire was supposed to be the signal wire for the MAF, but it actually ended up being that green wire. They had those switched around. The green wire on this diagram is for the IAT, but it's actually for the MAF. That blue is ground, and that gray/green is also ground. So here you can see we're actually looking at it on the car. You get that gray/green, which is ground, that red wire, which I believe to be the signal wire for the IAT, and then that green is the signal for the MAF. Blue is ignition power, blue/black is ground.
Alright, so now we have the car running and we're back probed on that mass airflow sensor signal wire. And we're reading voltage because it puts out an analog reading. And here we have some of the live data pulled up. We got grams per second, which right now at idle we're got around 4.2, 4.3. The car's not fully warm yet, so it should come down a little bit more. This is a 2.7 liter, so we should see that it'd be in the ballpark of 3 grams per second at idle with 20 inches of vacuum. But so I'm gonna have Anton in the car bring it up to 2,000 RPM and see what kind of changes we get. We should see our voltage should come up because there's going to be a little more air flowing across that sensor. So go ahead, Anton, bring it up to 2,000. So you can see our voltage is increasing slightly. So is the grams per second. Calculated load. Alright, now give the throttle a couple blips. You can see we're really jumping up here. A lot of calculated load, the air loading up in that manifold, and a high voltage reading on that signal wire, and flowing a lot of grams per second when he was doing that. Guys, so we thought it'd be cool here to show you the voltage on the signal wire for the mass airflow with it actually out. The key is on, the engine's off, so we're at 0.3 volts around, and I have this actually out of the airbox, and if I blow through it, you can see that voltage actually goes up because as I blow air across that heated wire, it's going to cool it down and it's going to take more current to heat it back up. So that's kind of demonstration on how that works. Okay, so here we're looking at our mass airflow readings, and we're gonna induce some unmetered air into the system by, I have this intake hose clamp undone after the mass airflow. With this screwdriver in here, you can see right now reading 3.3 grams per second and 1.1 volts on the sensor. If I open this up even more, letting more unmetered air in, you can see those readings go down. There's more air that the sensor's not reading is getting into the engine. Now we're going to take a look at the manifold absolute pressure sensor on the same vehicle because it is equipped with both. You can see we have a red/white, which is going to be our signal wire. It goes up to the PCM. Our gray and green wire is ground, and our gray and red is power from the PCM. So we're going to take a look at that on the car now. Looking on the car now, you can see this is our manifold absolute pressure sensor, and it's plugged right into the manifold, so you don't have to deal with any vacuum lines or nothing like that. I am tapped into our red/white signal wire. The car is currently off, but the key is forward, and we're reading 4 volts, which is correct. It should be high because that's when we're going to have a good amount of air in the manifold, and as you can see, we're at 14.6, close to that atmospheric 14.7 psi. So now we're going to run the car, and with vacuum, we should see that this reading goes down, because with vacuum you have less pressure. Okay, so here we're still plugged into that signal wire on the manifold absolute pressure sensor, and we're reading about 1.2 volts at idle, which is pretty much correct in that general range of where it should be. And we're reading 4.5 psi on the value for the scan tool. We should see, if we blip that throttle, we're going to load up that manifold with air, and it should spike up as we blip the throttle. But it should not be correlated with RPM, because as that RPM starts to come up, you're going to be using that air that's in the manifold, so you'll see that it starts to come back down after the engine gains RPM. We have Anton blip the throttle again, and we're going to look at the MAP reading. So go ahead. You can see it's spiking there quite a bit. Now bring it up to like 225 and hold it there. So you can see initially it actually came up, but then it went back down because we did load air in that manifold for a second, but now that the RPM's caught up, the engine's using that air. So now I wanted to show you the MAP readings when we induce a vacuum leak. So you can see we're at 1.2 volts on that signal wire, about 4.3 psi reading on the scan tool from that sensor. And if I unplug this vacuum hose here and make a vacuum leak, voltage reading goes up because we just added pressure into that manifold. Now if I plug it, it comes back down. You can hear starts to idle lower again. And you can see with the short-term fuel trims, it's making pretty quick adjustments to that vacuum leak as I let my finger off the hole and it's adding fuel to compensate for that extra air coming in. There it is, plugged it back up again, and you can see it's coming back down. Unplugged it, back up, more fuel.